So 5(1) is the roots of real numbers. Now, when we say roots, all we mean are the solutions or the answers. So when you hear the word roots, all we're talking about is solutions or answers. That's all we mean. It's like, what are the answers to this? So if something tells you to find the root of something, that's all it means. It's nothing major, just what is the answer. Now, I'm going to tell you right now that this one, as easy as it seems, is probably one of the most missed questions around. Because everybody thinks they kind of know what it is, and there's something that's wrong about what they've been doing. Don't let that dissuade you from answering, because there's part, we do need that part as well. So let's talk about the square root of 9. That means the square root of 9. What is the square root of 9? 3. Okay, so let's say we all agreed that it was 3. All of you just got half off on that problem.
Plus or minus 3.
Okay, so what we need to understand is that, here's a couple things. That when we talk about the square root, there's like a hidden 2 in here. And really what it means is that, you don't have to write that, but there's like a hidden 2. And it means that we're looking for a number that there are 2 of that exact same number, and when multiplied together will equal that. So it could be 3, or it could be negative 3, because negative 3 times negative 3, if I have 2 negative 3's, that will give me a positive 9 as well. So what I'm going to do is I'm going to write this as positive or negative 3. Now we tend to ignore that in geometry because those negative numbers, when we are finding the side of a triangle, we don't really care about negative numbers on the side of a triangle. But for you guys, because this is your first quiz come Friday, and some of you want to kind of change the way your grades went from semester 1, if that's you, then you need to make sure you're not losing 50%, 50%, 50% on these. This is an easy way to just gain those points. Simple questions. Again, 2 negatives can make a positive as well. So let's take a look at this. Now, this one is very similar. Notice that this part right here, I'm just going to put it in parentheses here just so we can kind of seclude it. This part right there is exactly the same. And what did we say that part equals? Okay, so that equals plus or minus 3. We agreed on that. That was the last time. But there's this negative out front being multiplied times it, which is kind of like a negative 1 out front. Well, we've got negative 1 times the positive 3 and negative 1 times the negative 3. So really our 2 answers, this is going to be kind of like people are like, wait, what? We had to do all that work? What is negative 1 times positive 3?
Negative 3.
That's a negative 3. And what is negative 1 times negative 3?
3.
It's positive 3. So it's still plus or minus 3. It just means that the negative is going to flop both answers, but it doesn't change the way you write the answer. You know what I mean? It's still plus or minus 3. It's just that the positive 3 got turned into a negative 3 and the negative 3 got turned into a positive 3. But the answers are still the same. Yes, ma'am?
I can't get to anything. I don't have the...
Okay, so have somebody airdrop it to you, and then you've got to talk to guidance because I can't add that class for you. I don't have that ability. So if for some reason you cannot access the class, you need to make sure you talk to guidance today because that would not be a reason for you to not turn in your homework. You have to talk to guidance today to get that taken care of. All right. Now this one is a little bit difficult here as it looks like it's really hard because you're like, wait, I have to figure out fractions. And you're like, actually, no, this is way easier than it looks. So most people hate that when they see a fraction here, but I bet you would be a little less intimidated by it if you knew that if we take the square root of a fraction, all it means is that we take that fraction and we take the square root of the top and we take the square root of the bottom, which is way better than the first situation. So what happens when I take the square root of the top? And what happens when I take the square root of the bottom? 3. So there's my answer, 1/3, but I just lost half my points. Why? Plus or minus. It could have been positive 1/3 that was multiplied by itself to get 1/9, or it could have been negative 1/3. Now that will happen as long as there is an even number hidden in here. And this is called the index right there. So if the number, now when we do square roots, that means that there's a 2 in there, meaning that we need 2 of those numbers. Other times it might be a 3, it might be a 4, and we'll talk about that when that happens. Now, this one looks really ugly, and this is the one that people really hate, and they freak out and they try to do weird numbers, but there's an actual super easy way to do this. I would definitely turn into a fraction. Now, here's how you turn into a very easy fraction. If you can tell me the name of this number, then you already know the fraction. But don't tell me it's 0.09. That's not the name. That is 9/100ths or 9/100ths. Notice that now it's a fraction. And I'm taking the square root of 9/100ths. Well, okay, that's better because it's a fraction, but why is this easier than it looks? What do I do with that fraction now?
You take a square root of each.
Square root of the top and square root of the bottom. 3/10. Now let's pretend that they wanted this answer. Let's say that they wanted this answer as a decimal. Yep, 0.3 or just 0.3. There's no difference, by the way, between these. Those are the exact same answers. Both of them are exactly the same. So either one of those would be okay.
Yeah.
You definitely would. That's where we're going next, is that each one of these would need to be positive or negative 3/10. So I don't really like working with decimals. A lot of time people prefer decimals, but you can see that there's an advantage in fractions sometimes. That you go, oh yeah, that's way easier than seeing. Like, you would have had to go through a whole bunch of numbers. Now, my guess is that let's pretend that you didn't know how to do that. You would probably say what times itself, and most people, when they write this, they'll do it wrong, and they'll do this. Which won't give you, like, take 0.03 times, or take 3/100ths times 3/100ths. Like, when you get your answer, you are going to end up with a totally different number than 3/10 there. So, should go through and work that out, and you'll see it is not the same thing at all. So, do not just look at it and go, oh, well, that's 0.03. That's not how that works. Make sure that you know that it's the same thing as 9/100ths, and then we take the square root of top and bottom.
Wait, does the 3/10 need a...
Yes, if we leave it, yes, if we're leaving it as a fraction, then that gets a plus and minus as well.
Is there anything that doesn't get a plus and minus?
Yes, that's where we're going. That's where we're going to go next. Some things won't, but don't worry, you'll actually be able to identify it really easy. It's a super easy way to identify it. You just have to be conscious of that. I'm glad you asked that question because you have to be conscious of it. But we're not there yet. First of all, it says find the real roots of each equation. When they say the roots, what do they mean? They just want the answers. That's it. Find the answer. That's all they're asking for. I say that because when we do these, a lot of times people are like, I don't know what a root is. And you go, it's just the answer. These are the questions you're going to ask me on quiz day that I can't give you the answer at that point. So I'd rather give you the answer right now. When it says roots, what does it mean? It just means, what is the answer? X equals what? Okay, how do I solve this?
Square root of x squared and
Good. We need to take the square root of both sides. But when you take the square root of both sides, you need to make sure that you add plus or minus. Because it could be two different numbers. Now, am I done there? No. So I'm going to show you something in a minute that is, I got to make sure that we clear this up. I'm not done here because there is still math to be done. There's still stuff that we can do. X would be equal to plus or minus what? 3.
Wait, so do we have to show the second step?
Which second step?
X equals plus or minus the square root of 9.
I would. You need it. In terms of homework, as soon as you take the square root, you must make it plus or minus at that point.
No, but like all I wrote was, I saw that and I just wrote x equals plus or minus.
So here's what I'm saying. So he's saying this. He's saying that he saw the first one and he went right to here and he went plus or minus 3. If you went from there to there, in terms of homework, I just gave you like a 40% on your homework. Here's what I care about. How did you get there? The thing is that you're going to have to do this. The whole point of homework is, I realize homework is not fun. It takes up a significant amount of your time outside of school, but it's the same stuff that you're prepping for the quizzes and the tests, which are a lot of them. And so a lot of times I had people whose scores would not have been passing scores in this class had it not been for how diligently they did their homework. They did their homework all the time and they showed their work, and that is what carried them into a passing grade. So just something to keep into consideration. That can be the difference between an A or a non-A, or an A or a non-passing grade. You know, that can be the big difference there. So I want to talk about something you got. Yes?
The x squared, does that just mean how two numbers?
Yeah, so it just means there's some number times itself that is going to equal 9, and our goal is to figure out what that number is. So the whole reason we take the square root is because to turn an x squared into an x, we would take the square root. The thing that times itself to give me x squared would be x. Now let's talk about something that you guys did last year, and I'm going to probably mess up some of these terms because I'm not really sure how you did, but I want to correct something. Last year, I know because I worked with people in like one-on-one from your geometry class, and you guys ran into these situations like this. Now, again, if you were in my class, if you were somebody who was with me for geometry, I don't need you to answer this. You've done this. I need the people who weren't with me to really take a look at this and go, okay, so how do we answer this? Like, what did you guys do last year? Because I know what the square root of 25 is, right? A number bigger than that. I know what the square root of 25 is. What is that? Okay, and I know what the square root of 16 is. So my answer must be in between 4 and 5. And you guys did something like that, right? I don't know what he called it, but it squeezed it. And so you guys made an estimate. That is not, definitely not something we're going to do in math classes here. Now, here's what we're going to do to correct that. It's not incorrect. It is a number between 4 and 5. That is completely correct. But that's not going to help us going forward. That's just an estimation, and you're just taking a guess at what the number is. We are going to come up with the exact way to do this. This answer is not finished, and we are not going to round it. We're not going to take a guess. But there is something called simplest radical form, and that's what we are going to be using, and that's what you will use in all your math classes going forward. So we're going to take a look at that. So now here's the thing. The square root of 20 is tough, right? We all agree it's not one of the easy ones to do because it's not 4 times 4 and it's not 5 times 5. So I don't know, some number in between there. So let's talk about what we can do. I don't know the square root of 20. I'm not lying when I say that. I don't know what times itself will give me 20. But what I can do is I know two numbers that when I multiply them together will give me 20. What are those two numbers? Okay, 4 and 5. So the square root of 20 is the exact same thing as the square root of 4 times the square root of 5. Talk to me for a minute about why do I love the square root of 4 times the square root of 5 way better than I love square root of 20? Yeah, because I know the square root of 4. What is the square root of 4? That's 2. Now, the square root of 5, the only numbers that multiply to make 5 are what? 1 and 5. So that's not going to break down to any better form for us. It's just going to stay as the square root of 5. This is called simplest radical form, and it's the broken down form of it. You need to be able to do it. I'm sorry that if you didn't get this last year, but I'm going to correct that right now, because going forward in any math classes, next year they're going to expect that you know this. It really is expected that you know this by the time you get here, but we're going to fix that now.
Would it be plus or minus 2 times?
No, because all we're doing right now is we're not going to break it up yet. I just want to show you how to do simplest radical form. We'll talk about that plus or minuses in a minute. But for example, let's look at the square root of 40 for a minute. Let's do one more like that. The square root of 40, I don't know. I do know that the square root of 49 is 7, and I do know that the square root of 36 is 6. So I can't just say it's some number between 6 and 7 and guess. That's a very inaccurate way of doing it. However, I could take that square root of 20 and break it down into two numbers. Now, there's lots of ways of multiplying to make 40, and I'm going to make this recommendation to you. Whatever numbers you pick, make sure that one of them you know the square root of, or else it gets much harder. So give me two numbers you can multiply to make 40 where you know the square root of one of them. 4 and what? 4 and 10. So the square root of 4 times the square root of 10 is 40. Which one of those do I know the square root of? 4, which is 2. Now the square root of 10, wait, that still breaks down, but let me just see something here. If I were to break that down, it would be the square root of 2 times the square root of 5. Do I know the square root of either of those? No, so that didn't help me, so I'm just going to leave it right here.
So you don't have to simplify.
It doesn't get simplified anymore because simplifying it anymore would not help me. It doesn't break anything down. So right there we leave it as 2 square root of 10. Again, this is called simplest radical form. If you didn't get it, hopefully that wasn't terrible. That's all it is. That's exactly how we do it. And we're going to be using that on some of these problems coming up. So let's talk about B. Tell me how to do B. Well, we have to subtract 4. That's what we have to do first. And we get x squared is equal to negative 4. Now what? Take the square root of both sides, and we get x is equal to plus or minus the square root of negative 4. Now, before you respond, do some thinking.
Yeah, but that doesn't work.
It doesn't work. Why not?
Because you can't take the square root of negative.
You can't, I should say, at this point, we very soon will be able to, but at this point right now, we cannot take the square root of a negative number. Think about it. 2 times 2 is 4. Negative 2 times negative 2 is positive 4. No number I can think of will work to do that. So do not write no solution. In this case, I want you to write something called no real solutions. Or it's actually called imaginary, is what we're going to get into. Or no real roots. These are both the same thing. They mean exactly the same thing. I'm just saying the exact same thing in two ways. You can say it either way. No real solutions or no real roots. We cannot take the square root of a negative number. We cannot find out what number times itself will give me negative 4. That doesn't make any sense at this point. There's no real number that we can multiply to get that. We will learn how to deal with that. So in this case, we just say no real solution, no real roots. That's the difference between these two.
Do we write NRS?
No, because that's not something we actually use all the time. And even if I let you do it in another class and they would just mark you off. So I'd rather get you in the habit of doing things that next year people will know what's going on. All right. So let's work some more with these. Again, you already know how to do most of these. Let's just work with them. Okay, talk to me about this one. Okay, and again, if you get stuck, remember this is 5 times x squared, so to get rid of that 5 times, we need to divide. Don't do the square root first. We need to get everything away from the x before we do that square root. So now we're at x squared. What is 15 divided by 5? 3. And now what am I going to do? Okay, take the square root of both sides. And when we do that, we get x equals plus or minus the square root of 3.
So you can't, obviously you can't square root 3, it would just be plus or minus 3, right? That's your answer.
Say it again, I think I'm with you, but I'm about to correct something, but I want to make sure it wasn't a mistake what you said.
But you can't break down
So what would you write as your final answer for this?
plus or minus 3.
Not plus or minus 3. So here's why. Check this out. I'm going to make something up. Don't write this. This is just something I'm making up. What is the answer to that? Forget about everything else I did. What is the answer to that?
Plus or minus 3.
X is equal to plus or minus 3. So this can't be the exact same thing.
Would you keep it as a square root? So you keep it as
We keep it as a square root. We can't break that square root down anymore. It is the simplest form already. When we have that plus that square root of 3, I can't break that down anymore. It's already as broken down. It's what we call simplest radical form. So we just leave it as, you don't have to write this again. I'm just showing you plus or minus the square root of 3. It doesn't break down. Please don't give me decimals, because here's the problem. You guys, sometimes people go and they start trying to figure out what decimals they can multiply, and then you do it, and as soon as you leave one number out of there, like some of these things go on infinitely. You leave out one number, you've already got it wrong. Wrong. Sorry. Like, I'm not trying to be rude about it. It's just not correct. Like, it's not me trying to be a jerk. I'm just naturally a jerk. All right, let's try one more. What do I do first? Divide by 6. Divide by 6. And you may not know what 108 divided by 6 is off the top of your head, but take a minute. You can figure it out. I know you can. Okay, so we get x squared is equal to 18. Okay, take the square root of both sides. And we get x is equal to plus or minus the square root of 18. Riley, you want to attack this one for me? You think you got it?
Yeah. So it'd just be x equals plus or minus 9.
What are
No,
two?
sorry.
What are two numbers I can make?
It'd just be square root.
Two what?
No, you can do 9 and 2. Oh, you break it down. Okay, so 9 and 2.
Now, why would I not use 3 and 6? 3 and 6 are good too, right?
Because they don't have square root.
Yeah, I don't know the square root of 3. I don't know the square root of 6. So use numbers that where one of them you at least know the square root of. What is the square root of 9? And what is the square root of 2? It's just the square root of 2. Plus or minus 3 square root of 2. 3 times the square root of 2. Yeah.
If you use different numbers, will you get the same thing? Like, if different numbers that would...
Yeah, so here's the thing. Let me show you that there's another way to do this, and it's longer. I'm going to tell you that I always try to teach you. I'm a lazy math teacher. Let me go back to this step right here. Let's say you did choose 3 and 6. It'll still work. It'll still give you the same answer, but you're going to see how much longer it is. Watch this. I'm going to still do the square root of both sides. I'm going to still do x is equal to plus or minus the square root of 18. But I totally forgot about 9 and 2. So instead, I said, well, let me break down 3 and 6. Well, neither one of those I know the square root of. However, 6 breaks down further, right? Into what? Okay, so we get the square root of 3 times the square root of 3 times the square root of 2. That's this one broken down right there, okay? Now, this will always be true if you run into a situation where you have two of the exact same square roots. They're exactly the same, right? Then multiply them together. It'll become the square root of 9 times the square root of 2. Now what can you do?
Break down the 9.
Now break down the 9. Notice we did all that work just to end up back at 9 and 2.
Can you just cross one out, or does it not always come to the same?
Like cross them out like this and write 3?
Yeah.
That will, by the way, I think what you mean is, this will always be true if this is what you mean. Check this out. The square root of 167 times the square root of 167 is 167. If you actually calculate that, that's what notice that the square root of 3 times the square root of 3, when we took the square root of 3 times the square root of 3, the final answer was 3. That will be true every single time you do that. You just,
You can, like,
You don't have to repeat that.
right, do you still have to write it out? Like where you wrote,
well, I would say this. If you got to this step here, if you went all the way in this wrong direction here, I want to know how you got out of it. Yeah, I want to see the work. Because you kind of went in a long direction there. So I go, yeah, how did you get out of that? Yeah, I want to see the work. Okay. Here is where I answer Ryan's question. Ryan said, is there ever a situation where it's not plus or minus? Okay.
the cube roots are different.
Yes, this is not a square root. We said with the square root. Now, here's the thing. I need to address this, and this part has got, like, you are going to make your life so much harder than it needs to be if you don't pay attention to this part. This number is called the index, okay? That number right there. It does not mean times 3. It just means that there's a number times itself 3 times that will equal 8. Now, if there is an index that is odd,
It cannot be plus or minus.
then there's no plus or minus. Because think about it. Let's take a moment here, and I'm going to just do this. What number times itself 3 times would equal 8? Okay, so we know that it's 2 times 2 times 2. But watch, that will equal 8. But look what happens with negative 2 times negative 2 times negative 2. What does that become? Negative 8, a different number, so that won't work. And that'll happen anytime you have odd numbers. So when you see your index is odd there, you're going to go, okay, there's no plus or minus on there. If it's even, there is definitely a plus or minus. Okay, now let's pretend everybody there kind of just shouted out 2. They were like, yeah, I know it's 2. 2 times 2 times 2 is 8, and you're not wrong. But let's talk about, well, what if you didn't know that it was 2? What if I was looking and they're like, wait, how did you all know it was 2? Here's a way that you can get yourself out of this situation. Let's say that this 8 here, I wasn't sure what times itself 3 times will do it. What times, give me 2 factors of 8. 4 and 2. So we get, like, we've got 4 times 2 underneath there, right? That's the same thing, right? 4 times 2 underneath there is the same thing as 8, yeah? But that 4 breaks down even further. What does that break down to? 2 and 2 times another 2. Now remember, what this asked us to do is it said, hey, find a number that times itself 3 times will equal 8. Well, look right there what we just wrote. There's a number that times itself 3 times will equal 8. Our answer is 2. Our answer is not the cube root of 2. It's not the square root of 2. It's just 2. 2 is the number that times itself 3 times will give us 8.
And it can't be plus or minus either. It has to be plus.
Because the index is odd, there is no plus or minus. If it were even, there would be.
As your answer, you would only put 2.
Just 2. Now, the biggest mistakes that I see, people write the square root of 2. They write the cube root of 2 as the answer. That is not the same thing. What this says in plain English, when we break this out of nerd speak here, is there is a number that times itself 3 times will equal 8. What is that number? That's what it's asking. And that number is 2. Okay. Is there a plus or minus on this one? No, this number is odd, so there's no plus or minus. You can't square root one. If that number is even, by the way, if that number is even, you'll never end up with a negative. But if it's odd, think about it. You could have three odd numbers. A negative times a negative times a negative will end up negative. So it's okay. We just know, the one thing that we know right away is our answer positive or negative? It has to be. It has to be some negative number times itself 3 times. So let's pretend some of you have already figured out what this number is. It's negative something. But what that something is, if you don't know, let's break this down. 27 can be broken down into what? 9 and 3. Now 3 doesn't break down anymore, but 9 does, right? What does 9 break down into? So the number that times itself 3 times that will give me negative 27, is the answer 3?
Yeah.
It's negative 3. Remember, because we said we needed a negative number. That was the key point in this, is that we go, oh, it can be a negative this time. It has to be negative. It can't be a positive, because 3 times 3 times 3 would be 27, not negative 27.
So the number inside the square root is negative, then the answer can be negative?
At any other time before today, I would have answered that question without a correction here, but that is not a square root, that is a cube root. So like, you got to understand, I'm only being a jerk about those terms because of today. That's very important, that what we're talking about.
On a cube root, though, if it's negative.
Anytime that index is odd, and you have a negative number inside, the answer is always negative. It has to be. There's no way, because only negative numbers can produce negative numbers. Positive numbers, think about it. There's no positive numbers that if you only multiply positive numbers that are going to end up being negative. All right. Now, I'm going to show you 2 different ways to do this one. You're going to now you can do this either way. One way is not better than the other. They're both good. One of them, I'll show you actually 3 ways. One of them is terrible. 2 of them are good. One of them is terrible. So the worst way that I think you could do this is figure out what 10 to the 6th power is. Just sit there and doing this. If you did 10 times 10 times 10 6 times, what you would end up with is this. That's the worst possible thing you could do. There's a way easier way of, like if you're going to sit there and try to figure out what times itself 3 times equals 1,000,000, then that is a very tough way to do it. I'm going to show you a much easier way to do it, and you can choose.
Subtract the index with the number that's
I think I know what you mean. It's not subtracting, but let me show you. Check it out. All right, let me show you the first way. Now, I like your way, and I actually want to show the second because that's my favorite way. Okay, so we've got 10 to the 6th power. Can somebody grab that door for me? Sorry, I don't know why the keys aren't working. That means that we've got 10 6s underneath here, right? That's what that means. 4, 5, 6. And we're looking for the same number being multiplied together 3 times. So look, here is a number that is being multiplied together 3 times. So I'm going to pull out a 10 on the outside because a 10 has been multiplied 3 times. Yes? Do we all agree with that?
Yeah.
But there's still 3 10s left inside. But guess what? I need numbers that have been multiplied together 3 times, and then they can come out. So out comes another 10.
Wait.
Oh.
Okay, so check it out. Here, on this first one, there were 3 10s being multiplied together. Remember, we need 3 of them. So we pulled out a 10. But there's 3 10s left inside. They were still inside. And they were like, oh wait, there's 3 10s inside. Let's pull out another 10. So what we're left with is 10 times 10, which equals? Okay. Now, I will tell you right now, 100 times 100 is 1,000,000. I'm sorry, 100 times 100 times 100 to the 3rd power. 100 times 100 times 100 is 1,000,000. That is the number we're looking for. But a lot of people said something that I want to address. That's not my favorite way to do it. That's kind of a long way to do it. So, what?
How did we get to 10?
So the first 10 came from here. There were 3 10s, and they came out there. Then we had these blue ones that were still left inside, and we had 3 of them, so they came out as well. Now, are you about to ask about the other way?
No, I don't know.
I think is it about the dividing?
Yeah, like.
Hold that thought, and if the next thing I explain doesn't answer that, because I think I'm going to answer your question. Remember that these tens here, here's a much easier way to do it. This is what I think if you can remember this. Like we have got a 10 to the 6th power. There are 6 tens under there. And we want to pull them out in groups of 3. We want to make groups of 3. Do you remember when you were in elementary school and we made groups? We took a number and made it into even groups. What did we call that? Like, was that adding, subtracting, multiplying, dividing? What was that?
It was something. I forgot what it was called. It was like.
It was one of those 4 things I just said.
Oh.
I want to take some, like let's say that I took a whole bunch of Skittles and dividing. We divide them into even groups. So we're going to take those 6 groups and divide them into 3s. Because every time there's a 3, right, we're dividing them into groups of 3. Why 3? Because that came from right there. That's this number. That's this number. Okay? What is 6 divided by 3? And what is 10 squared? Notice the exact same answer there.
Would that work for like any other number?
Okay, so the answer is yes, it'll work for any other number, but it works best when it divides evenly. If it were 9 and 5, yes, it still works, but you have to understand some deeper concepts first. It always works, but it doesn't always divide as evenly as that. If that were 6 and 4, it might have been a little bit different. Okay, so those are 2 different ways of doing it. I would not do it this way. That seems like a horrible way to do it. I'd be at that for a while. I'd be trying numbers all day to figure out what times itself 3 times. But the truth is that it is 10 multiplied by itself 3 times. I'm sorry, the 100 that'll get multiplied by itself 3 times. That will give us 1 million.
Wait, so what's your answer?
100. That's it, 100. 100 times 100 times 100. If you put that in a calculator, will give you 1 million.
That way is much easier.
I think so too, and that's why we'll try it both ways in the next one. You'll see that way is easier. Joe?
Can I ask you a question about the homework real quick?
No, because I'm still on the notes.
Okay.
Okay, but afterwards.
It was like
Because I may get to it, and maybe something I just haven't gotten to yet.
Yeah. Okay.
Okay, so that is 9 A's. There are 9 A's underneath there. So here's the way. This is what I think is a little bit harder, but if you're stuck, you can still do this. There are 9 A's. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 A's. I'm just going to double check myself. 2, 3, 4, 5, 6, 7, 8, 9. Now I need to pull them out in groups of 3 because they're saying what times itself 3 times. Well, there's 3 A's, so I can pull out an A. Okay? This is the first way. This is the way that people are like, okay, I didn't like this way as much. So there's 1 A on the outside. Now, again, just stick with me even if you didn't like this way. How many A's are still left inside? There's still 6 inside. 1, 2, 3, 4, 5, 6. But every time I see 3 A's, I can pull out an A. So now I have 2 A's on the outside. And how many are left on the inside? Another set of 3. But every time I see 3 A's on the inside, I can pull out an A. So I get A times A times A with nothing left inside. And A times A times A is what?
That's so many A's. Oh my god.
What is A times A times A?
8 to the 3rd.
A to the 3rd. Now, that is our final answer. But I think most of you are going to like the other way better. Check this out. There are 9 A's. And then we want to divide them into groups of 3. What is 9 divided by 3?
3.
I think that's way easier. Right? I mean, look at the difference between those 2 problems. One of them shows you what happens. One of them just shows you that's like, okay, put them into groups of 3, and every time you pull out 3 of them, then you have an A. So I can do that 3 times. Yes, sir?
So when it's the square root, can you imagine that the 2 is in the index and then we just do
Yes, this is a good question. So when he said, what about a square root? There's no number there. The square root is the only one that's not going to have a number in there. It has a hidden number of 2. Its index is 2. It's the only one that we don't write. When you don't write one in there, it's already, if you don't see a number in there, it is already a square root. It means that there's a 2 in there.
Can you always do that? Even if it's not a non-number?
If you don't see a number, what do you mean?
Yeah, like if it's a 2 or whatever number, like can you divide it?
Oh, yeah. Like you can always, sometimes it won't divide evenly, but for today, you don't need to worry about that. We're going to get to what happens when they don't divide evenly. But right now, that's exactly what we need, a to the third power. Now we are almost finished. And actually, I think these last ones go pretty quickly. All right. Talk to me about that index of 4. What do I know about the answer when it says 4?
Something that's 4.
It's plus or minus. That's guaranteed. It's going to be plus or minus. So already, whatever my answer is plus or minus whatever. Okay? So there's a positive and a negative. Why? Because that number was even. If it was odd, it would not be plus or minus. So I don't know off the top of my head what times itself 4 times would give me 81. So instead, what I'm going to do is break it down. 9 times 9, and it doesn't matter which factors you chose, they'll all end up the exact same. And this becomes 3 times 3 and 3 times 3. Now look, I'm looking for 4 of something that will come out there. Well look, 1, 2, 3, 4. My answer is what? 3. Plus or minus 3. Because remember, negative 3 times negative 3 would be positive, times another negative 3 would be negative, but then another negative 3 would turn it back positive. So as long as there's an even amount of negative numbers, it'll turn it positive.
Can I do that extra?
Sure. Okay, I took 81 and I turned it into 9 times 9. Are you cool with that? Okay, and then I took the 9 and I turned it into 3 times 3 and I turned the other 9 into another 3 times 3. Are we okay with that? Because what it means right there is 3 times 3 times 3 times 3. Those 4 3s, when I multiply them together, will be 81. It's the same thing. So 81 and 4 3s will be the same. Now, what this does when we do that is we are looking for, our goal is to find some number that when multiplied together 4 times will equal 81. Well, guess what? Here are those 4 numbers. The same number 4 times. Well, what is the number that multiplied by itself 4 times will equal 81? 3. That's how we found that it was 3. Now, why was it plus or minus 3? Because the index was even. So that's what we're going to do. Ryan, was that you said you wanted B?
Yeah.
Okay. Talk to me about what am I looking at first? Like, you know how I'm doing things here. What is the very first thing I looked at?
The 5.
The 5, the index. And what did that tell me?
That you need 5 of the same number.
Okay, but what else did it tell me because it was odd?
That you don't need the...
Yeah, there's no plus or minus. We don't need to worry about plus or minus. Is the answer going to be a negative number?
No.
No, it's definitely a positive number, whatever, because you can't multiply. It's not going to be negative, so we already know it's a positive number. So take it from there.
So you split up the 32 into 8 and 4.
And again, you can split it into any factors you want. It'll always break down the same way.
And then you split the 4 into 2 2s, and then the 8 into 4 and 2. And then you split the 4.
Let me just catch up. Notice that all I'm doing is breaking down each number. Now you said, I'm sorry, break down the 4?
Yeah, you break down the 4 into 2 2s. And then you have 5 2s. So your answer is 2.
So we have 1, 2, 3, 4, 5 2s. So the number that we're pulling out is a 2. And it's a positive 2. Now let's say you're not sure. You're like, well, how is it negative 2? Well, think about it. If I had negative 2 5 times, that's an odd amount of negative things. It'll end up negative, whatever it is. So positive 2. Do I need to leave it up there a minute?
It's not really 32 questions. There's 48 questions in the first 14.
Yeah, but a lot of them are really easy to come up with. They're super quick. So, all right, notice that B and C are exactly the same with the exception of one thing. So somebody help me out with C, but understand that it's basically the exact same thing except for one thing has been changed on C.
Negative 32.
Okay, so Joe, take it for me. What am I looking at here? What is the first thing I look at?
If you could break down negative
After. Okay, so say it again.
You could break down negative 32.
Okay, but what about this? What does this tell me right here?
Then you have a number multiplied 5 times the same number.
Okay, and what else does it tell me? Because it's odd.
That it's not going to be plus or minus.
Okay, so don't write plus or minus on this one because it's odd. Okay, so now we know that our answer, whatever it is it going to be a positive or a negative number?
Negative.
Only negative numbers are going to be able to make a negative 32. That's the only way that would happen. So now, don't worry about the positive and negatives. We already know the answer is negative. Just break down 32.
84. And then square root.
Okay. What are we breaking down?
The 4,
Okay. Into?
2, 2.
Anything else?
The 4, A is 4, 2. And then that 4 gets broken into 2, 2.
Okay.
Since there's 5 2s, it would just be 8, 2.
And again, we already knew that it was going to be negative. So again, it was the same as the last one. We knew that 32 broke down into 2. The fifth root of 32 is 2. But in this case, it was the fifth root of negative 32, which was negative 2. Oh, I'm sorry. I'll leave that up for a second before we move on. Okay. Last one we're going to do here. Ryan, who do you want to throw into the bus?
Yeah.
This one does take some thought here.
Riley.
What?
Why not Gabby?
I know, I got Gabby.
I would like to keep my.
I don't even know what to do. It's negative 1. What do you mean?
Okay, so let's talk about that. Like, I'm glad that you said it like that. I'm glad because actually there should be something kind of going on here. Talk to me about what you know. Let's just go into what we know and then we'll deal with what we don't know.
So it's going to be a plus or minus.
Okay, so whatever this answer is, the only way this could tells us that it's like plus or minus. So what times itself 6 times will give me negative 1?
Wait, say that again?
So what number times itself 6 times will end up being negative 1?
Negative 1.
Okay, so let's check that. Let's just verify.
Some would have to be positive, some would be negative.
Okay, so here's what I'm hearing. I hear that some people don't like that because they're like, wait a minute. If I have 1, 2, 3, 4, 5, 6 ones, this does not end up as negative 1. It ends up as positive 1. So what's the problem? What if it were positive 1? It would be positive.
So there's no answer.
But this goes back to something we said earlier.
So there are even numbers, plus and minus, and
So we would need both the plus and minus, but what number times itself 6 times will give me negative 1? There is no number. Remember when we said it has an even root? Any even root, if we have a negative number under there, it's no real solutions. There's no real number that will do that. And here's how you notice it. This is just a quick thing. By the way, if you want to not do all that work, if this number is even, it means that we're going to have like a plus or minus. But this one right here is negative. The only way that can be negative, the only possible way this could be negative is if this is odd. And that's not odd. So that means there's no real solution, or another way of writing that is no real roots. Both of them are exactly the same. Just in case you see it, they're both the same way of saying the exact same thing. No real solutions, no real roots.
Wait, is no real numbers the same thing or no?
No, because there are numbers that we haven't touched yet called imaginary numbers. And so you can't say no solution. Don't say no solution. There is a solution to this. And don't say no solution, and don't, like, that's all we can say is no real solution. There's no real numbers that we can use. Yes, ma'am?
The only way it's negative is only if it's odd.
Right. The only way you can have a negative number underneath there is if that is odd. Now, that's for real numbers. Now, we're going to get to that later and how we deal with that. Well, how do we deal with that? We'll deal with that later. That's it.